Nearly 6,000 feet below the Galápagos Islands, a robot crawling across black volcanic rock caught a flicker of something that shouldn't have been there. A tiny blue creature, barely bigger than a golf ball, sitting alone in total darkness where sunlight has never once reached. Scientists filmed it back in 2015, then spent more than a decade trying to figure out exactly what it was. It took a preserved specimen, a scanning tool that could see through solid tissue without cutting a thing, and a lot of scientific patience before anyone could say for certain this animal matched nothing else on record. What makes this little octopus so strange? How researchers finally proved it was something new? And why a creature this small could change how scientists think about the entire deep ocean? All of that is coming up. At first glance, this octopus looks almost too simple to be special. It measures only about 6 centimeters from the top of its body to its arm tips, small enough to rest in the palm of a hand. It has a squat little body and short, stubby arms instead of the long trailing limbs most octopuses are known for. Its skin is smooth and strangely free of the bumps, ridges, and color patterns other octopuses use to blend into their surroundings. Its arms carry just a single row of suckers, far fewer than expected for its size. And here's the detail that really stands out. It has no ink sac at all. Every classic octopus defense move, the panicked burst of ink used to escape a predator, simply isn't in this animal's toolkit. Then there's the color, a vivid, almost otherworldly blue, one of the rarest pigments found anywhere in nature. Scientists think that color might not be for show. Down in the deep sea, many creatures glow when disturbed, a built-in alarm system that tips off bigger predators to exactly where to strike. Researchers suspect this octopus's blue tone works like a filter, dulling the telltale glow it happens to brush against something bioluminescent while hunting. In a world without a single ray of sunlight, staying invisible to the right eyes can be the difference between surviving the night and becoming someone else's meal. A creature built this differently couldn't just get filed under an existing species, something had to explain it. Most octopuses researchers encounter extreme depth still resemble their shallow water relatives. In at least a few obvious ways, a longer arm here, a familiar pattern of skin texture there. This one broke from that mold almost entirely, which is part of why the footage sat unresolved for so long. Nobody wanted to name a new species off a single blurry clip when the alternative explanation, an unusual color morph of something already known, was still on the table, but proving that took a lot more than one grainy video clip. Back in 2015, a remotely operated underwater robot was exploring the seafloor near Darwin Island, roughly 1,773 meters down, when it spotted the little blue animal resting quietly on the volcanic ground. Researchers from the Charles Darwin Foundation and the Galápagos National Park Directorate eventually recovered footage and a specimen, but there was a problem. Darwin Island itself sits at the far northern edge of the Galápagos chain, a spot already known among marine biologists for the strange creatures that turn up on expeditions there, which is part of why cameras were even rolling at that depth in the first place. Deep-sea survey dives like that one are expensive and rare, often requiring a research vessel, a trained RAV pilot, and a full crew just to spend a few hours at the bottom before resurfacing, so every minute of footage collected gets studied closely long after the boat has come home. With only one confirmed specimen in hand, cutting it open to study its internal anatomy would destroy the only physical proof anyone had. So scientists turned to a different tool entirely, micro-CT scanning. This technology stacks together thousands of X-ray images to build a full three-dimensional model of the animal, inside and out, without ever making a single incision. Through that scan, researchers could examine beak shape, organ placement, and internal features scientists rely on to sort octopus species apart, several of which turned out to be missing or arranged differently than in any known relative. Combined with the smooth skin, the sparse suckers, and the missing ink sac, the evidence became impossible to ignore. In May 2026, the species was formally described in the journal Zootaxa and given an official name, Microeledone galapagensis. More than a decade after that first grainy sighting, a name finally matched the mystery. But naming a new species isn't just paperwork. This particular octopus was about to append a scientific assumption about where its relatives are even supposed to live. This technology stacks together thousands of X-ray images to build a full three-dimensional model of the animal, inside and out, without ever making a single incision. Through that scan, researchers could examine beak shape, organ placement, and internal features scientists relied to sort octopus species apart, several of which turned out to be missing or arranged differently than in any known relative. Combined with the smooth skin, the sparse suckers, and the missing ink sac, the evidence became impossible to ignore. In May 2026, the species was formally described in the journal Zootaxa and given an official name, Microeledone galapagensis. More than a decade after that first grainy sighting, a name finally matched the mystery. But naming a new species isn't just paperwork. This particular octopus was about to append a scientific assumption about where its relatives are even supposed to live. Here's where things get genuinely surprising. Microeledone galapagensis belongs to a family of octopuses called Megalelodonidae, a group scientists had long believed lived almost exclusively in the freezing waters of the Southern Ocean near Antarctica and tended to grow fairly large. This tiny blue octopus breaks both of those rules at once. It's small, it lives thousands of miles from Antarctica, and it turned up in deep, tropical Pacific waters right near the equator. That single discovery forced researchers to rewrite the formal definition of the entire family. And this wasn't just a one-off sighting either. A fourth individual matching the same species was later spotted on a seamount roughly 60 kilometers away from where the first one was filmed. That detail matters because it suggests this isn't some lonely oddball that drifted far from home. It points to an actual established population living quietly in these deep waters, which means relatives of this octopus are likely spread across far more of the world's oceans than anyone had previously mapped out. That raises a bigger question most people never stop to think about. Scientists have spent decades sending submarines and robots into the deepest parts of the ocean, and they still keep finding animals nobody has ever documented. That's because the deep seafloor is one of the least explored places on the entire planet, far less studied than the surface of Mars in many ways. Every trip down with a camera or a robotic arm has a real chance of catching something new on tape, sometimes years before anyone even realizes what they filmed. This particular octopus sat identified only as unusual footage for over a decade before the right tools existed to confirm it as its own species. That gap between first sighting and final proof is common in deep-sea biology, and it means the ocean is likely holding on to discoveries that have already been filmed and are simply waiting for someone to look closely enough. Like if that blue octopus surprised as much as it did the researchers who found it. Subscribe for more deep-sea discoveries and wild animal stories.